Hello everyone, in this video we're going to talk about how we can write fractions and mixed numbers as decimals. So we're going to do this by using long division, so hopefully you've learned that at some point in your mathematical journey. For a terminating decimal, we have a decimal that ends, right? So think about something that terminates, the end point, right? Termination. And so in decimal that ends, we would call it a terminating decimal. So you could think of something like 0.5, that would be a terminating decimal. Another type of decimal that we could have would be a repeating decimal, and that would be a decimal that has a pattern that repeats. So you could think about something that's like 1/3 as a fraction. If you divide that, you're going to get 0.3 repeating. So it's like 0.33333333, and that continues on in a pattern. We do also have non-repeating and non-terminating decimals. Those would be considered irrational numbers. If you want to know more about rational and irrational numbers, you could take a look at the first video that I made for pre-algebra, and that goes over the real number system. So I can actually link that video in the cards right now. Well, let's get into it. Today we have 4 examples where we're going to write fractions like on 1 and 3, or mixed numbers like on 2 and 4 as decimals. So as we look at number 1, we have -6/5. Okay, so for this one, we can operate this. We can use our long division as if there was not a negative there, and then we could just put the negative in our decimal at the very end. So 6 divided by 5, we could think about our long division. And when we see how many times 5 goes into 6, that would be 1 time. And then 1 times 5 is 5. And we go to subtract, and we're left with 1. Okay, so we could write this would be like 1 1/5, right? But we're trying to write it as a decimal. So to do that, we're going to change 6 to 6.0. And so now what I can do is I can drop down this 0, and my decimal that I had, I'm going to put up into my, my quotient here, my answer, in the same place that I have the decimal under my long division bar. So now we're going to say, okay, how many times will 5 go into 10? Well, it'll go in twice, and 2 times 5 is 10. And now here we subtract and we end up with 0. So when we end up with 0 down there, we know this is going to be a terminating decimal. So our answer is 1.2, but we know that it should have been negative. So we can say -1.2 would be our decimal for -6/5. All right, number 2, we have -6 and 3/8, so we have a mixed number. So if you'll notice on 2 and 4, we have mixed numbers. So we'll do these differently. For number 2, let's write this as an improper fraction, and then we'll divide from there. So remember, to do that, we're going to take our denominator times our whole number, which would be 8 times 7, that's 56, and then we add 3, so this would be 59/8, and it is negative. So now we can divide that, so 59 divided by 8. Well, 8 will go into 59 7 times, and 7 times 8 would be 56. We subtract and we're left with a 3. So let's do the same thing, let's make this 0.0 and bring down our 0. So when we do that, we add up our decimal behind our 7, and now 8 will go into 30 3 times. That would be 24. Well, we still don't have 0, so let's add another 0 and bring it down. Now 8 will go into 60 7 times, and that would be 56. We subtract, we still don't have 0 at the bottom. So let's add another 0 and bring it down, and now 8 will go into 40 5 times, and 5 times 8 is 40. So now we know we have our terminating decimal. Okay, so for this one we could say our answer is 7.375, and we need to tack on our negative because our fraction was negative at the beginning. Okay, all right, number 3, we have 3/11ths. Okay, so now this is the first one that we're going to do where our numerator is smaller than the denominator, so we're going to end up with 0 point something. So for this, we're going to put 11 outside of our long division and 3 on the inside. Well, we already know that 11 will not go into 3, right? It's too big. So we need to go ahead and add our decimal. So let's add our decimal up here. And now let's see, will 11 go into 30? Yeah, it will, it'll go twice. And 2 times 11 would be 22. 30 minus 22 is 8. Okay, well, we still don't have our 0 at the bottom. So now let's add another 0 here and bring it down. And let's continue dividing. 11 will go into 80 7 times. And 80 minus 77 would be 3, still not a 0. So let's add another 0 and bring it down. So now 11 will go into 30 twice, and now we have 22. We subtract again, we get 8. Still not 0, so we bring another 0 down. 11 will go into 80 7 times. We have 77. We subtract with a 3, and now I think we're seeing our pattern, right? So now it's going to be 0.272727, right? So now we have a repeating decimal. So now we could write this one as 0.27, and then we're going to put a bar over our digits that repeat. Okay, so 0.27 with a bar over it, that's a repeating bar. So that indicates that it's 0.272727, so on and so forth. Okay. All right. For number 4, we said that number 4 is also a mixed number like number 2, and we're going to do them differently. So for number 2, we rewrote the mixed number as an improper fraction. Let's actually keep our mixed number separate here. We have 1 5/27. So we know that our decimal is going to be 1 point something because we already have a whole of 1, right? So if we noticed here, we had -7, and then we also had -7 as our whole for our decimal for number 2. So let's just divide 5 divided by 27 here, okay? So let's put 27, and I'm going to go ahead and draw a little bit of a longer division bar here, and we have our 5 right here, okay? So we know that 27 will not go into 5. So we need to go ahead and add our 0.0 and put our decimal up there, okay? So now we know that 27 will go into 50 one time, and 1 times 27 would be 27. Okay, now we subtract here, and we're going to end up with 23. Now 27 will not go into 23, so we need to add a 0 and bring that down. So if we think about 27, how many times will it go into 230? Well, 27 times 10 would be 270, right? So it should be something close to 10. So if you want to kind of guess and check, you could do 27 times 9. Well, that's 243, so that's too much, right? So we need to do 27 8 times. So we put our 8 up here, and 27 times 8 is 216. Okay, now we subtract again, we end up with 14. 27 won't go into 14, so we need to add a 0 and bring it down. Now once again, we can try and guess and check some numbers. Let's say 27 times 6. Well, that'd be 162, which is too much. So we know it needs to be 5 times 27. So we're going to put our 5 right here, and 27 times 5 would be 135. We subtract, we're left with a 5. Still not 0, so we need to bring it down. Well, now notice what's happening. We're back to 50. 50 is where we started, right? So maybe we're going to see our pattern emerge here. We said 27 goes into 50 one time. 1 times 27 is 27, and 50 minus 27 is 23. We add our 0, we bring it down, and now we have 230 again, right? So we said that goes in 8 times, and 8 times 27 was 216. We subtracted here to get 14. We bring down our 0. Once again, we had a 140, and we said that 27 will go into 140 5 times, and that is 135. Okay, and now we have a 5, and what would happen? We'd bring down another 0, right? So now we're at 50 again. So we see our pattern, right? Our pattern would be 185 is repeating. So our decimal would be 0.185 repeating, and then keep in mind we had this 1 initially, so we're going to put that right there. Okay, so instead of 0.185, it would be 1.185 repeating. Okay, so that would be our answer for number 4. All right, and that is how you can write a fraction and a mixed number as a decimal.